As soon as you open the window, go to Tools, Options, General Options. In 3D Modeler drawing, make sure both this and this must be checked, and then go to hfss. In boundary assignment, these both must be checked. Insert hfss design. So this is a window where we will build our inductor or whatever may be the device. And first we'll build substrate, and then we'll build silicon dioxide. Over that our inductor will be, and this whole thing must get enclosed in air boundary. And this are the coordinate axis. This is positive y, positive z, and positive x. And so if you click this, you will get top view, side view. If this tab is not visible, then just right click it, then go to view, apply orientation. Here you can see all those things: top view, bottom, right, and so on. If you want to set any material, select a material from here. Before building that particular object, you select a material from here, and in hfss we must be aware of each and every coordinate. If we simply build without knowing the coordinates, so there might be a problem of mesh. So first we'll build substrate, which is nothing but silicon, whose relative permittivity is 11.9 and bulk conductivity is 10. Then first select, add material, substrate, okay, draw box. This position will give the uh, coordinates of the bottom vertex of your box. So you have to mention the coordinates according to your dimensions. This is the size of the box. So here in size, if you give plus, the box gets constructed in the positive axis direction. If you specify minus, the box gets constructed in the negative axis direction. Here this is fit all the contents in the view. If you click, so all the contents gets fitted. Now just click a side view, then you can see we have started from here and the box has got constructed in the positive z direction. 240. Yeah, I just forgot to mention the units. We have to change the units. modular units. Acronym. Check the properties. Now this hole must be in micrometer. Fit it. Now next we have to build a silicon dioxide. Again go to select, add material. Its relative permittivity is 3.9. Again draw a box. Now this is silicon dioxide. This one is silicon dioxide. We also will build the air boundary. Select air, you can select directly from here. Sorry. Go to top view and then draw the box. Now its position, we can take it from -300. Just check it in a side view. Now this hole is air boundary. Both silicon dioxide and substrate are in the air. We can change the names of these boxes also. Now if suddenly you have to change some property of a material, just click on that material, properties, and view or edit materials. So this is air, you can edit any of these properties. Now go to top view. Now I have to build the spiral inductor over the SiO2. SiO2 is now in the top of SiO2 is nothing but the z equal to 0 plane. So we'll remove all these things so that we can clearly view the. Now we'll remove all these things so that we can properly view only the inductor which we'll build. So go to edit, by name, so everything has got selected. View, visibility, hide all views, everything has got hidden. Now we have to build an inductor which is made of metal. So select aluminum, As it is octal, it must be of 8 sides. Okay. Center position is the center of your polyhedron, and start position is again the one of the vertex of your polyhedron. Now this inductor is getting built in z equal to 0 plane. Height, I'm taking it as 0.85. Sorry, actually in place of number of sides I had written 0.85, that's why I had got the error. So I'm doing it again. Okay. Now draw another. So one ring has got formed. Now similar, two more rings we have to form. I'll name it as okay. Sorry, I took a regular polygon. Delete it. Now again, make sure which name you are placing under which thing. Like regular polyhedron 3 must be in blank parts and regular polyhedron 4 must be under tool parts. One more ring we have to construct. Okay. Let's start from minus 14. 70 comma 0. Let size be a bit more. 20. Okay. I think Y size must be 28. I'm sorry. X size must be 28. Y can be okay. Even 15 is okay. Yeah, it must be reverse. So click this box to end this, and both outer ring and regular polygon head and 3 must be this side. Then only that part gets removed. Similarly, we need to draw a box. You can see it clearly here. This part has not get subtracted, so it is better to change the properties. Let the position of y is something like 65. Then it actually box starts somewhere from here, and this whole part gets removed. Similarly, this side. Now this 3 must be removed. This whole part gets etched. Box. Again, height is 0.85. Position is you have to bother about this distance, y distance, sorry, x distance. Y size can be anything, so x size must be similar to that 28, and even the x position also must be from minus 14. Okay. Okay, see this. Now we have to build wires. 4 wires here. One will be here, one will be here, and one will be here, and one will be here. And this height of wire is 0.1. It is below the z equal to 0 plane. So draw box. Y size must be 6. Height is minus 0.1. And exercise, yeah, we can take according to our wish. I- Okay, now we'll take the X size according to our wish of this box. We'll keep it as 4. Okay. Now one more via here. This will just name it as via 1. Okay. So I'll cancel and just delete it. It's from 14 and 61. Must be 0. Minus 0.1. This is VR2. This also must be 0.1. If plus 0.1, it will come towards positive direction. So now if you want, you can just view that it will be below this thing. Zoom it. You see this part. Now this thing is uh, the ring, and this is via. It is below. Via acts as a connection between two metal layers. Now we have to build one more via here and here. $79 0 minus 14. Okay, and one, yeah, we'll just name this as, okay, I think I hadn't given Z size. Okay, 0 70. Oh yeah, again I forgot Z size. Save what you have done till now. Now we have to connect this both rings and these both rings. So this connection must be beneath the wire. Even this connection must be beneath the wire. This will be the top layer only, normal, above the zero plane. So this connection will be from below, that is equal to minus zero point 0.1 plane beneath that. Okay, first I'll connect these two. Draw a line. Here you can see the coordinates of the line. 61, and this must be 0. Now select that line. Again draw, sweep along vector. Zero, and this is 6. After sweeping, you have to thicken the sheet, so you should give some height. Go to modeler, surface, thicken sheet, just 0.85. Okay, you can see it. Okay, now this is below this. We have to give thicken sheet as minus 0.85. You can see this is above, this is exactly this. Now you have to unite this both. Now we have to connect this both. We also built this thing and then we'll connect them. So draw a line. Select it. Here you should give positive 0.85. Now you can check. See, now this is proper. Now unite this, this and this. This must not be under vacuum. So change the properties. It must be of aluminium. Now all these must be united. Now they have got united. Now I have to build this connection. So first we'll just, okay, This also must be of aluminum. Okay, this Z must be minus 0.1. We have to draw this polyline. Once check the coordinates. Select it. Sweep. Okay. Modular surface thicken sheet must be minus 0.56. Okay. Once check how it is built. This is below this, it's proper. Now you have to draw one more underpass here. Yeah, we'll just change the properties. It should be of aluminum. And name is underpass 1. Okay. Now draw a line. Okay. $85. Okay. $76. Okay. Okay. Now again select it. Sweep. Okay. Thicken sheet. Now again you can check it whether it is beneath or not. You can see this is via 3, and beneath this we have the underpass. Okay. Now we'll build an PC ring. Select PC. Okay. Box. Yeah, just put it some 140 to 140. Okay. Draw one more box. Minus 135. 6. I'll keep it minus 134. Now this is the outer ring. Now we have to connect them. So first draw a box. Let it be 84. And draw one more box. Let the size be same. Let this be again minus 84. Box 6. X must be 6. Okay. You have to change the position also. Sorry, it must be and these both must be of aluminium, so make it aluminium. Okay, you have to unite this and this. They have got united properly. I'll just name it as spiral. Okay. Then we have to connect this both. So first I'll draw the ports, rectangle, okay, and let this be some point to construct a rectangle here. See the properties of this rectangle, and one more rectangle here. I should check properties. They both must be of same length and breadth. Okay. Now we'll draw a box, and now material must be PEC. We'll draw a box from here to here. Okay, size is 6. Point 850. Okay. You have to unite these three. They have got united properly. Okay. This is our whole system. Now we have to give excitations. Air must be given excitation radiation. Now after the building these ports, here you have to keep the solution type as terminal. Okay, now select this lumped port, box 7. Okay, again assign excitation lumped port. Okay, Okay. This is not proper. I'll do it once again. I'll do the excitation once again. Now this is proper. Okay. Now we'll assign a solution setup. Okay. Check it. Everything is okay. Analysis setup. We add a frequency. Um, Sweep from zero point 0.1 gigahertz to some 20 gigahertz. Let it be linear step sizes 0.1 gigahertz. Delete it. One is enough. Okay. Now we'll perform the simulation. We have got this output. Everything is fine. No error. We have to observe the inductance. Inductance, we have to add an output variable. So in hfss we'll get only the parameters like s parameters and y parameters. Using these parameters you should write an equation for inductance. Go to y parameters and take the function imaginary part of y11, insert to, it's 2 pi f This is the inductance value as it is in nanohenries. Just convert it into 10 per 9. So the value which we'll get on the Y scale is nothing but in terms of nanohenries. Now add it. So in results, we have to trace it, create report, we just click any one of it. These are the Y parameters. I actually need output variables. Um, L sweep new report. So this is the inductance. If you want, you can just zoom it. As we need it at 2.4 gigahertz, we'll just zoom it at 2.4 gigahertz. We'll see how many nanohenries we have got. See, it's somewhere near 5.5. It's 5.6 nanohenry. Okay. So this is how we will do the simulations. And the value of inductance always depends on the width of the ring, spacing between these rings, and distance of that ring from center. If you want any more variables like quality factor, as we added the inductance, we can add those output variables and can plot them. So these are nothing but the parameters, Y parameters. Similarly, you'll get S parameters.